Okay, guys, we're going to go through the notes for 15.1 and 15.2. So you guys should be grabbing stuff to take your own notes, putting whatever you feel like is important. So with 15.1, when we're looking at it, this one's going to be talking about life and all of the different types of Earth systems. So when we're going through this, we're going to be looking at the biosphere and then all the spheres that make that up, as well as how do biotic and abiotic factors wind up working together with this whole thing. So the first thing we're going to start with is the biosphere. Now with the word biosphere, bio, if you remember, literally means life. So that's why we're studying biology, the study of life. So that's the first part. So then sphere, pretty self-explanatory. It literally means ball. So basically what we're looking at is a ball of life or a sphere of life, so to speak. Now the biosphere can be broken up into several other parts to it. So we have on the side here, we have the arthrosphere. Okay, that would be the humans. We have the cryosphere, which that's anything that involves ice, so glaciers. We have the hydrosphere, that's the water. Now usually the cryosphere and the hydrosphere are considered one. And then we have the biosphere, which the biosphere is technically involving all of these. So like I said, that's the life sphere. So anything living and anything it needs to survive. The lithosphere here is the Earth. And the lithosphere is also sometimes called the geosphere. And then finally we have our atmosphere. So that's the air and everything that's part of that. Now the way these kind of all interact together is picture your biosphere is the main part. Now within this biosphere you have a smaller portion that's called your biota. Now the biota is just all the living things. And then the biosphere itself is everything that's alive and everything it needs to survive. Now everything else is going to be part of the biosphere. It will overlap with it because everything else is required for life. So over here you'd have another sphere coming off of it. That would be your geosphere or your lithosphere. You're also going to get your hydrosphere. Because everything that's alive requires water of some sort. And like I said, the hydrosphere also includes the cryosphere. You're then also going to get your atmosphere. Now, some things that are included in each of these. So with your atmosphere, it includes all of the air. So it includes gases like oxygen, carbon dioxide, the ozone. Those are the big ones that everything needs because the oxygen is what animals breathe in, carbon dioxide is what plants will take in, and then the ozone is what protects us. But it also includes everything else, including things like methane or nitrogen. So it's any of your gases. And then it would also include clouds and things that are forming in there. So water vapor is also up there. All right, and then with your hydrosphere, it's any type of water. So you're going to have lakes and ponds, your ocean, and then like I said, it includes the cryosphere, so you'd also have things like glaciers and so forth. And then the geosphere, this is any kind of land feature, so mountains, even plains, your wood, any kind of land area. So even the plains minus the living things, any kind of land. So it could also be underwater trenches, so anything that involves the crust of the earth would fall into that category. So those are all your spheres, and like I said, they're all part of the biosphere. So the biosphere is everything that needs to survive, and so that goes on. So that's basically the first section. Now, with the second section, if you're looking at climate versus weather, there's a big difference between the two, but they are both very important when it comes to your biomes and what's happening. So we're going to be looking at what's the difference between them and what factors will actually affect your climate. So when it comes to climate versus weather, with weather, weather is simply your day-to-day activities. So that would be short-term things. So anything short-term like a storm, a hurricane. Now, while I understand those things can take a while, like a few hours in that, it's still considered short-term. It can even be things like it's sunny outside or it's cloudy outside, that type of thing. Whereas climate is long term. It's going to be year to year. Now with this is going to be things like the average precipitation, average temperature. So instead of saying, oh, it rained like an inch yesterday, you're talking about an average of, say, 200 inches for the entire year. Or instead of talking about, oh, it was 32 yesterday or 97, depending on what time of year it is, you would say we have an average conditions that range from, say, 32 to 97. And we're usually somewhere in between, depending on the season. So even with seasons, weather could include different parts of your seasons. So like with winter, there's snow, that would be a weather thing. Whereas in the summer, you get sunniness or rain. But the actual seasons themselves kind of fall under that climate category because they happen every single year. Now, things you can put into the middle category that they both have in common. They do both deal with precipitation. They also deal with temperature. Now, like I said, with the weather, it's what's happening right now, whereas climate's going to be something that happens over long periods of time. All right, now we don't just have normal climate, we also have microclimates, which microclimates are the climates over a small area. And it's a climate change, basically. It doesn't fit into what's actually normally happening there. All right, so a couple of examples. One example would be over here. We have an oasis in a desert. So the oasis has a lot more water and plant life than the actual desert itself, whereas the desert's going to be a lot more drier and have less places where you're going to have water and vegetation. And the vegetation is going to be different. In the oasis, you're going to get more water, water needing plants, whereas in the rest of the desert, you're going to have water resistant plants like cacti. Another example could be mountains or even just hills and things. This one side is going to be a little wetter and get more sunlight versus the other one. So in our picture here, this one's focusing on the actual mountain type thing. So on one side of the mountain, you get a lot of rain. And we're going to talk about why in just a little bit. Whereas the other side gets very little precipitation. And part of that has to do with the idea of wind traveling in a certain direction. So wind usually travels that direction from, in the case around here, it's going to be from west to east. And so the sides on the west get more rain, where the sides on the east get less rain. So that would be another example. A couple of other examples could be even simpler, like here, this is the idea of the area around a pond. Because in these areas, the surrounding area that's farther away from the pond might have low vegetation, but usually around ponds, you get big areas of shrubs and cattails and things like that. And the temperature and precipitation is going to be a little different right next to a pond versus farther away from it. Another example can be woods near cornfields or other fields. So the field has one type of kind of reaction, and then the wood would be another. Like if you ever walked from a field into the woods actually has a lot more rain. It's a little more moist, and it tends to be cooler because it has that blocking of the sun with the canopy in that. Whereas the field's going to be a little more exposed, so it's going to be a little drier out there. So there's lots of different types of microclimates. They just happen to be different from their surroundings. All right, now if we look at some factors that can affect climate, one such factor is going to be the sun. Okay, the sun is actually the biggest factor in the temperature and the climate of an area. And so the reason why is because of the latitude. Now remember, latitude is going to be the horizontal line. So these would be your latitude lines. Okay. Now with the latitude, depending on which latitude you're at, you get more or less sunlight. So around the equator, you get the most direct sunlight. That's because the rays come down straight. Now if you keep looking, as you go either farther south or north, in some places it starts getting slightly less direct. And so those areas are only getting some sunlight. Now they're getting more than others. If you go towards the poles, you're going to see that it gets even less sunlight. It's less direct. It's basically bouncing off and not getting as much. And so this is what winds up creating our climate zone. So we have 3 climate zones. We have the polar, we have temperate, and then we have our tropical. Now in our picture here, to let you kind of know where they're at, the part that's on the equator, let me erase this real fast. So the part that's here around the equator, that's your tropical. And it's tropical because it does get that most direct sunlight, so it's going to be a lot warmer in these areas. They're going to stay more around 70 degrees and then can get a little higher, but they're going to stay nice and warm like that. They're not going to see freezing temperatures usually. So then our next area, our temperate, is going to go between 30 degrees north and 30 degrees south, and that's going to be your temperate areas. Now the temperate areas are going to still be pretty warm because they are still getting that sunlight, but they're going to be a little more moderate. So instead of normally staying around 70 degrees, they're going to have a little bit cooler temperature sometimes. They're also going to be more likely to have seasons, whereas the tropical is always nice and warm. Temperate will have more of a fluctuation. Now seasons are not just caused by solar energy. Those are caused by the tilt of the Earth. But don't get mistaken. The tilt of the Earth does not affect the climate zone. It affects seasons, so be careful with that. All right, so then we get to our polar zones. Our polar zones are the ones that are going to be from 30 degrees north to 60 degrees north, and then 30 degrees south to 60 degrees south. Now the polar zones are going to be a lot colder because they're getting less direct sunlight, so they're not getting as much warmth coming. So they're going to stay colder more often. They're also going to have more snow and permafrost type things because of the fact that they're not going to warm up. All right, now going along with solar energy, we also have the issue of the greenhouse effect, which with a greenhouse, the whole purpose of a greenhouse is to be able to keep heat and absorb sunlight energy to keep your plants warm throughout the year. So you, in theory, could set this up even in the winter and it would keep them warmer than they normally would be. Now, the way this works is basically you have your sun, radiation comes down from the sun, it's going to heat up the earth, and then what happens is over time, those substances on Earth that have absorbed heat will radiate it back. So buildings absorb heat, streets absorb heat. That's why when the sun goes down, some things will still stay a little warm for a little while because they've absorbed that heat and then they radiate it. So then what happens is this radiation goes back up into the air and into the atmosphere. Now, once it's in the atmosphere, there are several different types of gases that will trap in the heat, and those are called greenhouse gases. Now, some different greenhouse gases. Water is a big one, so water vapor. Now, we enjoy water vapor. We like it, we need it because we need the water, we need the precipitation, but it does trap in heat. Another example is going to be carbon dioxide. So we always hear about CO2 emissions and how awful they are from our cars and different factories and how that's adding to the greenhouse gases and going to heat up the earth. It's true, they do affect it, but there's also one more that's a lot worse, methane. Methane is a much more potent greenhouse gas. It will trap in far more radiation than carbon dioxide. Now, the methane in the world is still our fault, sort of. So just like the carbon dioxide is our fault. But with the methane, the reason why that's such a big problem is because we create methane from the destruction and the breakdown of substances in landfills, so that produces methane. But the true number one producer of methane is cow farts. I know that seems a little weird, but your cows do produce methane gas from eating it, and because we have so many cows on the planet, because people like to eat steak and things, it winds up creating far more methane than even our car emissions. Now, they're all so bad. Now, why do we care about these gases? Well, like I said, they trap heat in. And when they trap heat in, they radiate some of it back down to the surface again. So it's keeping the earth warmer than it normally would be. Now, the greenhouse effect is a good thing though. Okay, that's how we're able to survive here. It does keep the earth warm enough so that we don't freeze to death and things like that. So it's good to have, but if you get too many greenhouse gases, then we start getting global warming, which will then cause your ice caps to melt, have global climate change, all those things. Another factor that's going to affect our climate is going to be wind and ocean currents. So if you've never paid attention, okay, with our wind currents over here on the side, weather goes in a particular direction. So like for example, where we're at, we would be part of the westerlies here. What that means is weather goes from west to east, which is what happens around here normally. Now, occasionally you do get a few fluke storms that will go a different direction, but normally weather goes from west to east. If you lived farther south, it goes from east to west. This all has to do with the currents of the wind. Now, with wind and ocean currents, warm wind or water will rise. This is kind of like in your house. If you're heating your house, the warm air tends to rise, and then what happens with the cold air? It sinks. So cold wind and water sinks. And so that's what's happening in the airflow here with the wind currents is you've got the equator where it's heating, and so you're getting more heat, so it's causing the air to rise, but then eventually that cold air comes back down towards the equator because it's cool, and then it'll get heated back up, so then it'll go back up, and it just keeps going in this kind of cycle. And then it's the opposite for farther south. You switched around. Same thing with our water currents. If you look in our picture here, so here you've got the equator down here. So then the warm water rises, and eventually that warm water cools down, and then it sinks back down. Or if you're going south, warm water rises. Now I realize it's going down, but you got to think in terms of the water. And then the cool comes back to the equator. So it keeps cycling back and forth like that. And so these will actually cause different places to have different temperatures. That's why if you live on the coast, sometimes coasts tend to be warmer, but it's also why living on the coast it could tend to be cooler. It depends on which type of current you're living next to. Now another big part of it would be landforms. So depending on what kind of land area you have, that can also affect the temperature and your different precipitation. So part of it, if you live in a very flat area, you're going to stay warmer, but you're also going to get colder at night because there's not as many things to hold in the heat. Whereas if you have a more populated area, it'll tend to absorb more of that heat and hold on to it. Another example would be mountains. Okay, with mountains you get the rain shadow effect. And what this rain shadow effect is, it's the idea that as air rises, it cools. So that's what's happening over here. Warm, moist air is rising. Now, as warm, moist air rises, it's cooling. Well, when air cools, it condenses. So then we get this cloud formation happening. So that's what's happening on this side. We get our cloud over here, and then it starts raining everywhere. Now, when it's doing this, it only rains on the one side of the mountain. Now, the reason why only the one side of the mountain gets rain is because by the time it reaches the top, it's basically expelled all of its precipitation. And so then by the time it reaches the other side, it's completely dry air. Plus, when you have dry air, okay, at this point it's raised up so it's cool, the cool air will then sink, and then eventually it's going to go back through the process farther on where it's going to get warm and then rise again. So it's cool air sinks, and it has no rain left, has no moisture left. So then that other side is extremely dry. And if it's dry, then it's not going to be able to sustain as much life. So this is why mountains tend to be an example of a microclimate like we were talking about earlier, because the one side has all that warm, moist air that rises and then it condenses and it rains on it. And then the other side tends to be extremely dry because all the moisture is gone. And so then it's just this dry kind of wasteland on the other side. All right, so that is it for the first two sections of chapter 15. Make sure if there's anything you're confused on, go back and watch the video again and help yourself remember.